I'm warning you in advance. You do need to try to master and understand well. Okay? So, it starts out pretty easy, and then it's going to become a little bit more complicated. But if you'll do what I'm asking you to do, which you're not going to like, I'm just going to tell you now, you're not going to like it, because you think it's going to take you more time, but it really won't, because your brain won't be so confused. Please take off your hoodie, please. Come on. Thank you. I promise it'll go quick. If you'll just do it my way the first time, you won't get as confused and be stumbling around so much. Then when you get good at it, you can undo it and do it more your way, okay? But in the beginning, please try to follow what I'm talking about. So we're going to start off by discussing what is a monomial. Mono meaning one, right? So I'm going to have one term. That term can be made up of a number or a variable or the product of a number and a variable or more than one variable. What does product mean? Multiplying, okay? So I could have something like a 3n. That would be a monomial. I could have a 3xyz. That would be a monomial, okay? It has to have a non-negative exponent. That's a weird word, non-negative exponent. So what does that mean?
Positive.
Positives? Then why wouldn't they just say positive exponent? Is there a non-negative number? Is there a non-positive number? Huh? 0. So we can have an exponent of 0. That would be non-negative. It's not necessarily positive. So you may come across a 0 exponent in the future. I don't believe you have any today, but coming very soon, like maybe Thursday, we're going to get them. Okay? So they're around the corner. So these are monomials, or examples of monomials. Here is an example of a monomial. That could be written like this. So a fraction is okay, but there's a very special type of fraction that is not okay. Just any, huh? No. If I had this flip-flopped like this, and I had a variable in the denominator, that is bad. That's not a monomial. Because this could come, someone could come along and go, hey, make that a 0 for me. If we didn't put rules on what the x could be, and you have a variable in the denominator, you get this really weird, let's say 8 divided by 0, enter. You get a divide by 0 error. So when you divide by a 0, your calculator freaks out. The world turns off its axis a little bit. Tidal waves probably happen, tsunamis, I don't know. So that's why, you know, it happens. Somebody divided by a 0, I'm sure that's the reason. But you want to never do that, okay? And in math, it's a huge, huge, huge thing to avoid. So if ever you're asked, is this a monomial, you're going to go no, and you would say because there's a variable in the denominator. So if there is ever a way to make the denominator a 0, the answer is no, okay? Now let's move to some more basic stuff. Back in the 6th grade, I believe it was probably the 6th grade, you learned about bases and exponents. The base was whatever the number was here, variable was here, and the exponent told you how many of them you needed to multiply together. So for example, if I had an n times an n times an n, and I wanted to write that with an exponent, I would say the base is the n, and how many of them did I have?
3.
3. So it's n to the 3rd power. Okay? We're going to be doing a lot of that today. But check this out. Suppose I had n to the 3rd power times n to the 2nd power. This is a monomial times a monomial, so this is a product. These two together make a monomial. what would this answer be? I would have 3 n's here. I would have 2 n's here. So what would your answer be? N to the 5th power. What we're learning today is how to write this correctly, because it's going to get big and crazy here in a little bit. The way you could write this would be you take your base, and what we really did was we added our exponents together to get our final answer. That's the rule. If you have matching bases, you add the exponents. Does that make sense? Okay. That's essentially the start of our notes. So let's look at the first example and get busy here. All right. It says to simplify this, and you're like, wait a minute, Miss S. What's up? What's up? Okay, because right now I feel like you're not paying attention. This could be a problem very soon when you have homework. Okay? Notice you have coefficients here. You have a 3 in front of this x and a 5 in front of this x. And what kind of math are we doing here? It's all multiplication. You don't see any plus signs, do you? So when I'm multiplying bases that match, I will add their exponents. So the first thing I'm going to do is try to deal with the coefficients. So look what it says. Group the coefficients and the variables. All right, if I group the coefficients, I am not going to ask you to do this part right here. I am going to ask you to try to go here first. Notice they separated the 3 and the 5 away from each of their terms, and they put them out in front. That would be good. Then they looked at the variables. Okay, I have an x to the 6th and an x to the 2nd. Notice how they wrote it. X to the 6th plus 2. Multiply your coefficients together to get the 15. Add your exponents on the variable together to get 8. You finished your problem. It's not an overly difficult concept. If your bases match, add your exponents. Do your coefficients first. All right, so look at the try it right below that. Here's where I'm going to ask you to do something you're going to find annoying, but I promise you to try to do it, please. When you have a problem like this, I would beg you to rewrite it first, making sure everybody has an exponent, because if you don't see an exponent, there is a 1, and you're going to forget to add it in every single time unless you write it to begin with in the beginning. Okay? So we have matching bases. All we have to do now is add our exponents. So my final answer here would be a 6. So y to the 6th would be a final answer. See if you can do the try it 2 right next to it. Remove your coefficients first. How did you do? Did okay? Okay. So far, so good? Yes, ma'am.
Question about the first one.
Yeah.
Since there's 2 lines, let me add the last one.
Because what we're really doing, if I'm going to show you something here, okay? This is like saying 1y times 1y to the 5th, okay? What's 1 times 1? 1 y to the 1 plus y to the 5. Okay? If we were adding, you would get a 2. 1y plus 1y. Okay? Good question, actually. All right, let's look at example 2. It's a little bit bigger. It has more than one variable. So back up to example 2 here. Okay? Once again, I don't care if you do this, but I do expect you to kind of show me some work here. So I'm going to take the -4 and the +3 and bring them out front first, and they made our -12. Now I'm looking at my variables. I have an a to the 3rd. In the next one I have an a to the 2nd. So I'm going to write a to the 3 plus 2. I'm now going to move to the b variables. I have a b to the 1 and a b to the 5. Combining like variables here and their exponents, your final answer is negative 12, a to the 5th, b to the 6th. So is it any different when I have different variables? No. Just group them together and add their exponents. See if you can do number 3 and don't freak out because it's a fraction. You're going to have fraction problems on this assignment. You have a calculator that does fractions beautifully if you don't. So learn to use it and use it well. Remove your coefficients out in front. 5 times 1/5. So I've got those two taken care of. Give everybody a 1 so you don't forget them. No, can you not multiply it by in your calculator? Because so it turned into a decimal on you?
Well, you can't turn it. You can't fraction.
Yes, you can. Parentheses, 1 divided by 5, close your parentheses. That becomes a fraction. And then times it by a 5. You should get the answer 1.
Yeah.
Okay.
Yeah.
Yeah?
Do you have to put the 1 in the front? Or
No, you don't have to. That's going to be to me, that would be simplifying it completely, would be to remove the 1 in the end. I'm not going to be grumpy either way, though. Okay. Yeah, it's okay. So here we would have a to the 3rd, right? B to the 2nd, and C to the 7th. If you really wanted to simplify it all the way, you would remove the 1, because 1 times a bunch of junk is just a bunch of junk. And so your final answer, truly simplified, would be this. So I removed the 1. You don't have to. I'm not going to count it wrong if you don't. But what do you notice about this answer? What do you notice? Huh? Okay, what else do you notice? There's something you should notice. Yes, sir. Thank you, Ryan. Yeah, your answers, your variables need to be in alphabetical order in your final answer, okay? We good? Okay, that's the easier part. Now we're going to take it up a notch. Are you comfortable with the easier part?
Oh, yeah.
All right, we're taking it up a notch. Do you need some help?
No, I just wanted to.
Okay, all right, that's fine. I just want to make sure you're okay. All right, now, that was when we had bases that were matching. We added the exponents. Now, we're going to have something called a power to a power. That means when you have something that's going to be already in parentheses, and it has a power once, but on the outside of the parentheses, you have another power. That's called a power to a power. And I have a little jingle. Power to a power stays in the sky. All you have to do is multiply. I know, it's so clever, isn't it?
Do we have to memorize that?
Okay. You're going to want to memorize it. I'm not going to ask you to repeat it for anything, but it will be very helpful. And we're going to make rainbows today. So, yeah, so pay attention. Shh, pay attention. Here is the one thing I'm going to ask you to do that you're not going to like to do, and it's you give everybody a 1. Okay? So, look at this mathy language example. Okay? When you have a problem that looks like this, okay, I would love to see you rewrite it as a to the 1, b to the 1, raised to the m. Because this is saying power to a power stays in the sky. All you need to do is multiply. This is what your answer would look like. This number to the m power, this number to the m power. Because you're going to have a lot of stuff and it's going to get confusing, and if you don't have ones, I promise you're going to mess this up. I've been teaching this 9 years. I know where your spots are you're going to mess up. You need to trust me. Alright, let's look at this first example. And I, quite frankly, don't care for anything that they did here. I'm just going to be honest with you. I don't like anything they did there. Isn't that terrible? Let's do this from the beginning in a good way. Alright? First thing I'm going to look at is, do I have a power to the power? So do I have a set of parentheses and then an exponent on the outside? Yes. So that means I'm going to rewrite each of these things with an exponent of 1 if they don't already have an exponent. That would be my first step, is to give everybody a 1. Okay? Sorry, it's a little bit faded. Now I'm going to power to a power. It stays in the sky, meaning I keep my exponents up high. All I have to do is multiply. So here's where the rainbow comes in. 3 to the 1, 3 to the 1, 3 times the 2. So this becomes a negative 2 raised to the 3rd power. I have an a to the 3rd power. And now I have a b to the 6th power because I'm multiplying. Over here I'm going to get what? A to the 8th power. What is, now I'm going to deal with my coefficient. What is negative 2 to the 3rd power? 2 times 2 times 2. 8. And since there was an odd number of them, they're going to be negative. So it's going to be a negative 8. Now I'm going to look at my variables. I have an a to the 3rd. I took care of him, and plus 8. Took care of him. Then I have a b to the 6th. My final answer is right here. Negative 8, a to the 11, because I'm going to add the 3 and the 8 together, b to the 6th. I just like the way I write mine way better than theirs. They have too many parentheses and too much stuff going on. Okay? So let's see if you can do the first try it. See if you can do the first try it. It's pretty basic, but I'm still begging you to rewrite everything. The minute you see a power to a power, you rewrite everything with an exponent of 1, even your coefficients. Now do your rainbow. Power to a power stays in the sky. We have a negative 3, always in parentheses, raised to the 3rd, a to the 3rd, and when I multiply, b to the 12. What is negative 3 times negative 3 times negative 3? Perfect. Negative 27, a to the 3, b to the 12 will be your final answer. Do you have any questions? Did you do okay on that one?
I don't know if you got 27.
Negative 3 raised to the 3rd power is saying negative 3 times negative 3 times negative 3. These two multiplied together make a 9. 9 times negative 3 become negative 27. Okay? Let's look at the second problem. Once again, it's a power to a power. That means I'm making ones. So I'm going to have a negative 4 raised to the 1st power, x to the 1st power, y to the 1st power, all raised to the 3rd power, times negative 2 to the 1st power, and I already have x already has an exponent, so he's good, Power, 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 power. So, -4 is now raised to the third power. X to the third power, y to the third power. -2 raised to the third power, and x to the sixth power. You doing okay? Bring your coefficients out front and simplify them if you want to as soon as you can. -4 to the third power is -4 times -4 times -4, which is -64, right? So -64, so I took care of him. -2 to the third power is a -8. So these guys are multiplied together. Notice everything's all multiplied together. I have no idea. 512?
Yes.
So 512 is what my number turns out to be. Now I can look at my variables. I have an x to the third, took care of him, and an x to the sixth, so +6, and then y to the third. Final answer, 512, x to the ninth, y to the third.
What's it that how you got the -8?
Okay, the -8, this -8 came from right here, -2 times -2 times -2. This becomes a +4 times a -2, -8. Okay? All right,
Yes.
y to the third. All right, see if you can do that last one on your own. You can do it. Rewrite a bunch of ones. I promise it seems like a pain, but it really is the best way to do it. That -3 that's out in front is not affected by the exponent, is it? Just place him out in front. Don't do anything to him. How did you do? See if you didn't get it, see if yours, if you can figure out where it is you fell off the bus. And then talk to me. Anybody get it right? Good. How many of you messed up right here, the 2 to the 4th and the 4 to the 2nd. You didn't get 2 16s. Did you get an 8?
No, I didn't.
I got 260. I got it. It's just fuse right there.
Oh, okay. So this is where I looked at the numbers, and I put all of the things that were just numbers out in front. Okay? So that's kind of how I scan it first. I look at the problem, I break it down to give everybody their exponents, and then I go back through and I analyze it. Okay, you're a normal number, you're a normal number, you're a normal number. All you guys have to come to the front right now with me. You're in trouble. You're coming to the front. Okay? Then I deal with the exponents. I try to deal with the normal numbers first up front. Okay? Okay. Your assignment's at the top of the notes. It's 17 problems. I'm going to help you with the first 2. They're quick, but I want to make sure you understand them. Okay?